Today we are solving systems of equations with three variables. So here's my sample problem. I have an x, a y, and a z in all three problems. This can take up a lot of paper, so get ready. Your first step is to eliminate one variable in two pairs. So what I've done is I wrote the first equation and the second equation, and then I wrote the second equation and the third equation. And what I'm noticing is that in the second equation here, I have a single y. So that's the variable I'm going to try to get rid of. In this problem, it's negative 2y, so I need to make this one positive 2y. So I multiply by 2, gives me this new equation. I add them together, and the y's have gone away. Now I have this equation with only two variables. Down here, I have a plain y and a negative 3y. So I need to make this one positive 3y. So I multiply by 3, results in this equation. I add them together. Now I have this equation. So these are my two new equations that I'm going to take on to the next step. Whoops. Hey. Okay, this is the second step. I have these two equations. Now this looks familiar. It's two equations, two variables each. Same as last time, I'm going to eliminate a variable. I have a 6 and a 12. I'm going to change this one to positive 12. So I'm going to multiply by negative 2. That changes all of my signs. But now when I add it up together, the z's go away and I just have an x. Now I can solve for x. X equals negative 1. I'm partly done. I take that answer, x equals negative 1, and I go back one step to either equation that only had two variables. And I plug in negative 1 there to solve for z. Now I have x and z solved for. My last step is to solve for that third variable. So I go back to one of the original equations. It doesn't matter which one. I picked this one. And I plug in what I know. I know that x is negative 1. I know that z is 7. The only thing I don't know here is y. Now I can just solve for y. I get y equals negative 5. And this is how I write my answer. The variables in order were x, y, z. So I write my answer as negative 1, negative 5, 7. That problem that we just did is an example of a consistent independent system where you get a real answer. And you knew you were going to get a real answer because when you solved that first page and you got two new equations, you got two equations. Okay? If that happens, you know you're going to get one answer. If you had solved that first step and gotten a statement that's true, like 0 equals 0, and in an equation, you get a 0 equals 0 and an equation, then you can stop there because you're going to have infinitely many solutions. If you had gotten a true statement and a false statement on that very first step, a false statement being something like 0 equals 5 or some other nonsense that's just false, then you know there are no solutions and you can stop there.